Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Revenera. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have another exciting presentation for you today. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab. You can find the Q&A tab on the right side of your screen, where you will also find that chat tab. We want you to use the chat tab mostly for getting to know your fellow audience members or just letting us know your thoughts throughout today's program. We do also have several handouts available for you under the Handouts tab, so feel free to navigate those and download at your leisure. And we do have a couple of polls that we'll be launching throughout today's program, so we do really want your participation there as well. And of course, before we close out, we are going to be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So on to the topic of today's program, manage software ingredients for complete transparency. And I'm joined today by Alex Ryback, Senior Director of Product Management at Revenera, Martin Callanan, founder and director of Source Code Control, and Sean Geary, principal solution engineer at Revenera. So Alex, Martin, and Sean, thank you all so much for joining me today. Alex, do you want to get us kicked off from here?
Yeah, absolutely. Thank you, Cody. Appreciate it. And thanks, Martin and Sean, for joining me today. So I might apologize ahead of time. I'm battling a cold here, so my voice kind of goes in and out. So I'll power through and we'll do what we can here. So we're going to do this in a few parts. So we're going to start by doing kind of a quick industry overview and update you where the industry is as far as regulations go. We're then going to throw up a couple of polls, as Cody mentioned. We'll do kind of a discussion around challenges and operational impact around the topics we cover. Then Sean will do a demo, and we'll wrap up by going through some steps you can take right away to kind of improve what your company is doing around supply chain security. So to start, let's kind of talk about why we're here, right? So the main reason that there is risk in the software supply chain and why SBOMs have kind of become one of the more popular terms in the industry is because software is no longer being developed by your internal team. So if you kind of unwind 20 years or so, most of the development that was done by your product team. You had complete control over the code. You may have here and there pulled in some third-party content, but typically it was done based on a commercial contract between you and outside developers. And there was lots of controls around all the code that ultimately made it into your product. Today, it's very different. Developers are essentially free to source code from many different places. Some organizations are kind of very nicely organized with policies and kind of locked down as far as where you can go get code. A lot of companies are not. And there's lots of immaturity as far as how a developer obtains code, how they get it reviewed, how they get it approved, and how it ultimately makes it into the application. So today, the way that development typically works is when you look into your product, it is comprised of commercial packages. It's comprised of open source components, and many of them, and it's comprised of proprietary code that kind of stitches everything together and is an implementation of your proprietary algorithms. However, if you kind of go a layer deeper, you will see that commercial packages contain open source components themselves, as do other open source packages. And very often your proprietary code may also contain open source content, even though it's not a monolithic package. There may have been a copy-paste event. A developer may have read a blog or an article or a book and grab some code from there. So at the end, you end up with kind of a mixed bag of code that your team wrote, code that comes in from known sources and trusted sources, as well as code that is maybe coming from an individual developer you've never met, never talked to, never vetted. So you keep accumulating risk as your product gets developed further. So I really like this comic. I've seen it for lots of years, and it's very relevant these days, right? So kind of the sad truth is companies spend a lot of money building out infrastructure, running lots of different security tools, investing in lots of processes to ensure that everything is reviewed and managed, and there's alerts if things change and so forth. But if you are leveraging open source, which most of us are, there is likely a low-level application that never got a lot of thought. It was permissively licensed, didn't have any vulnerabilities, so it was likely auto-approved through whatever process you have until it breaks. And then this whole kind of house of cards falls down. So if we kind of go back to December of last year when the Log4j vulnerability occurred, that was the exact scenario, right? Companies had spent a lot of money, lots of scans, lots of tooling to make sure that their applications were vetted and were scanned and were cataloged. And then a kind of the ubiquitous open source logging library that everybody who had a Java backend in their application was using had a critical vulnerability. And all of a sudden, everybody stopped. Everybody had to go back and assess, had to figure out where this library is being used, both in the products that they build, as well as in any commercial applications that they had deployed. So this became fairly disruptive, right? Lots of companies kind of almost had to shut down from an engineering perspective and run this assessment cycle, spend days to weeks to really vet what's going on and where the component is used and what version you're on, and whether the way you're using it actually exposes you to the exploitation. So this took a lot of time and cost a lot of money. And the challenge is that Log4j is maintained by 3 developers. They are not paid. They started the project due to their own reasons. And meanwhile, they ended up with millions of people that rely on this as a core component in their application. So when something went wrong, there was no infrastructure, no process, no commercial backing to ensure that this was quickly resolved. And this is the case for lots of open source components, especially ones where you're not sourcing it from a reputable source, where you're kind of at the mercy of the maintainers. And typically it's going to be a small group. Again, it will not have commercial backing. They won't be paid. They're not necessarily motivated to fix it quickly. So it's really important to kind of understand all these building blocks in your software and make sure that you know what you would do if there's an issue with any particular one. And there's actually a really good article here. We'll provide the link down the bottom right here that talks about kind of the toll of this Log4j scenario and how the industry kind of viewed the developers and the maintainers, and a real call for more industry and commercial backing for maintainers of these components that are leveraged by thousands of companies but don't really get funding or support to make sure that they maintain their projects. So I wanted to spend some time here and talk about software supply chain. And we always like to throw this up because I think there's a really good analogy between the hardware side of the world and the software side. So both hardware and software use lots of parts. So on the left here, if you look at a Boeing airplane, there are millions of parts. They're not flat. They come in sub-assemblies, and these sub-assemblies get built into larger sub-assemblies, and eventually the plane gets put together. So if you look at kind of what's going on in hardware, well, Boeing's got thousands of suppliers. They're all vetted. They're all registered. They're all part of an ecosystem. They're all tracked using ERP software. They all go through certification. There's regulations on the level of quality that they have to provide. And there is a clear process on if any particular part fails, who built it, who sourced it, where do we go to fix it, what's the criteria based to which the part has to be constructed and manufactured, and what happens if a particular vendor fails a certain number of times. Do they get replaced? Do they have to recertify? So it's very mature, and there's lots of processes and regulation in place to make sure that airplanes don't have failing parts. And most importantly is when they do, we know how to fix them. If you look on the right side, there's a graphic depicting a typical software application. So today we're seeing definitely more than half, in some cases up to 90% of an application comprised of third-party content that did not originate with the team that wrote the product. So we have monolithic packages. We have single binaries, right? Just a DLL inside your application. We see single files, so just an individual JavaScript file, for example, and code snippets, right? A lot of these things, again, come in uncontrolled. There is no partner ecosystem. There is no universally managed set of software suppliers, right? So the sourcing process is very much bottom up, where every developer can go essentially grab what they need, versus hardware world where it's very top down, right? The vendors and suppliers are selected and they're curated and they're managed. And in reality, when you look at this, you see in Boeing's case, they build about 20% of the plane. So they build the tail fin, they build the rear fuselage, they build the fairings to connect the wings to the body, and that's it. Everything else is built by suppliers all over the world, in a vast partner ecosystem, and then Boeing glues the plane together. So very similar on the software side, we see 20%, sometimes less, of the product actually comprised of proprietary code. The rest is gluing open source pieces together and making the application work. So the biggest difference between the two scenarios here is just the level of maturity, right? So the goal in the industry is to increase the level of maturity around software and get it closer to where we see hardware today. And this requires process, tooling, training, and community participation to make sure that we understand where parts are sourced from, what happens if they become non-compliant, and where do you go to remediate. So on our side in Revenera, based on our audit practice, we are seeing about 2,300 parts on average from every audit that we do. So that means if we scan a customer's code base, we typically end up seeing 2,300 pieces of open source, third-party commercial content in their applications. That's about a 15% increase between 2020 and 2021. And we're also seeing on average around 215 security vulnerabilities with each scan that we do. Right, so lots of content, lots of open source being used, lots of vulnerabilities. So the question is, how do you manage all of this? So we're going to spend a lot of time today talking about software bill of materials. So I wanted to take a moment here and define it and make sure we all have kind of a common definition of what we're talking about. So software bill of material in layman terms is your ingredient label on your software. Right? It is a formal and queryable record that contains details and relationships of various components used in building software. So what does that mean? It means that you need to know who supplied the part, so the software component. You need to know when this bill of material was constructed, what tools were used to construct it, what application and version of the application does the bill of material represent. You need to have a listing of components and versions with a unique identifier so that both the supplier and the receiver of the bill of material are talking about the same part. And you need to have relationships, right? The software parts are not flat. There's dependencies, which means that the part that you have in your product may be because you rely on it, or maybe that a piece that you rely on in turn relies on that particular part. So it's important to understand the provenance of the parts. If there's a failure on a particular part, so if there's a vulnerability, or if there's a licensing change, for example, you need to be able to understand, where do we go to fix it? Does our team fix it? Is it a direct dependency of ours? So we have to modify what version we need to pull in. Or is it a transitive dependency going back to a dependency of our dependency? In which case, you don't want your product team fixing it. You want to make sure you upgrade to the latest set of components. So it's important to understand the relationships, understand the provenance, so we can get back to who needs to fix it and where do we source a patch. Now, NTIA has come up with this minimal definition. CISA, which is the cybersecurity government agency, is now charged moving forward with further refining SBOMs, both around the definitions, around the roadmap, and the growth of the SBOM. So definitely keep tabs on both of those entities to make sure that you stay up to date on the latest definition and the fields associated with software bill of material. Excuse me. So let's talk about the external forces driving software bill of material adoption. So you can see here on the top right, there's lots of acronyms for the different agencies that are involved with software bill of material definition, as well as the rules behind it. So today we have a mandate. We had a White House executive order around cybersecurity that came out in May of last year. And it was definitely not the first piece of legislation to talk about software bill of material. It's actually been discussed for over a decade. There's lots of other industry activity around software bill of materials, from healthcare, automotive, energy, consumer, lots of EU regulations that Martin will talk about in a moment. But this White House executive order really kind of gave a push to organize, to get industry feedback, to make sure that companies weigh in on how they see the problem, what they see as part of the solution, to collaboratively define a bill of material and minimal elements, to collaboratively define what a critical piece of software means, because it can't be everything for everybody, right? There's got to be some level of prioritization and classification to be able to attack the problem. So that's what's transpired over the past year and a half, because there's been lots of industry activity, there's been lots of feedback, and we're now at a point where there are concrete rules. There's been a memo issued about a month ago that really puts this executive order in force and explains to the various branches of the U.S. government and various agencies how their software and hardware sourcing requirements are going to change based on the executive order and what they need to do with a given timeline and a given dates on various processes that they have to follow. Likewise, in the EU, there's been a draft Cyber Resilience Act, which essentially is very similar to the executive order that talks about what do you do when you store software products and the intelligent hardware with software on it. So there are lots of kind of industry regulations, lots of push depending on what various industry you may be in to provide more transparency into what is inside the hardware and the software that is being sold. So if we move on from mandate to process, there is a great industry organization called OpenChain. It's the international standard for open source compliance. There's work going on that Martin will talk about to expand this from license compliance to also include security assurance standards. So that's work that's underway today. And this is essentially a process that organizations can follow to make sure that whatever governance program they are running has kind of checked all the boxes, right? So think of it as a quality assurance spec on measuring your quality program and measuring your open source management program to make sure they have people properly trained, put in the right places, that they're held accountable, and that you have a process that's mature and is able to keep up, is able to scale, and is able to identify issues as they come up. And then finally, the kind of the most important part is for software adoption to scale and to take off, there has to be cooperation between organizations. So there has to be a way for one company to share data with another, make sure they're talking about the same parts, and make sure that they can programmatically communicate. So there are industry standards around software bill of materials. So the software data exchange format, it's been around for about 12 years, is an ISO standard. It is a bottom-up view to a bill of material, and its focus is on explaining the licensing for every single file inside of a given application. So it's a bottom-up kind of file level view that tells you here is the licensing for a given file, and here is the package that that file belongs to. Cyclone DX, which is another standard, a little newer standard, and it is more of a top-down view, right? So its view is here is a listing of components that are inside your application. So both of these are live specifications. Both of them are going through revisions. So there should be new versions of each specification upcoming in 2023. Okay, so with that, I will turn it over to Martin to talk a little bit more about the specifics of these various regulations.
Thanks, Alex. As Alex just mentioned, software bill of materials, as a term, has been around for many years. We've worked with companies, I don't know, Revenera. I've worked with companies to audit code and create a report called a software bill of materials. I'm actually old enough to remember when it was just called a BOM, a bill of materials. But what's changed over the past 2 years, there's been a shift from software companies should manage and track components, third-party components that are used in developing a solution to you have to do that. And the reason is primarily because of security, of course. There's been an increase in particularly state-backed attacks on infrastructure, both in Europe, US, and other parts of the world. What's got the attention is the White House executive order, which Alex has mentioned already, which has actually gone through Congress and has become a bill. And that bill is called the Department of Homeland Security Software Supply Chain Risk Management Bill. And as Alex mentioned, now that bill's in play, there's now a timeline of activity that software companies have to adhere to. And it's not just a case of producing a software bill of materials. The data in the software bill of materials that is being reported on has to be attested. So basically, companies will be certifying all the components that they declare are in the code are free from security vulnerabilities, which obviously is quite an onerous task, and a lot of people aren't actually aware if that level of detail is going to be required. But it's not just about the US. Even that requirements in the US affects companies globally. We work with companies around the world, particularly in Europe, India. They all export, or most companies do export into the US, and are finding they're going to have to look at the US strategy, what they need to do for that. But then there's legal requirements happening in Europe and other parts of the world. So I've listed three recent publications from the European Union. The first is very similar to what the US are doing. It's termed the EU Cyber Resilience Act. And the European Union has got the same challenges as the US. Infrastructure is being attacked by state-backed hackers, and exploits have happened, so it needs to be addressed. So they've looked at the White House work and the Congress bill, and they're creating their own act. In that act, it states that there has to be a software bill of materials with any software supplied to government agencies. Alongside that, you have to attest it. The European Union is going a stage further. They're stating that they are probably going to define what is the formats of the software bill of materials. So you could find yourself in a situation where if you sell both into the US and into the European Union, you might have different formats that you have to adhere to, which again will be another challenge if you're that software company. And prior to that Resilience Act, for certain sectors, the EU published, for instance, for companies developing IoT solutions, again, there's a requirement that there should be a software bill of materials, both for the kind of devices, maybe embedded devices, but also the back-end systems that the devices report into. And in the arena of cloud, there's a cloud services scheme, which again calls out the need for a software bill of materials. So it's the common theme is software companies, developers need to be tracking these third-party components. Outside of governments, if you look at industry verticals, for instance, the Payment Card Industry Association, they've got a software security framework, and that calls out the need to track third-party components if they're vulnerable, but also have a strategy for remediating those. So the inventory equates to a software bill of materials, and organizations like the FDA for a number of years have called out the need in things like medical devices to track third-party components, and if they're vulnerable, and create software bill of materials. So I suppose the takeaway that I would say to the audience is, if you're not looking at it, or you think it's not an urgent requirement, increasingly it'll be difficult to sell your solutions into particularly government institutions. Alongside that, I would just say as well, we are seeing increasingly procurement departments issuing tenders for software solutions, requesting software bill of materials as well. Now, obviously, this is a challenge for a lot of people. Fortunately, the industry has come together and are collaborating to create standards and best practices. So Alex touched on OpenChain. Do you want to bring up the next slide, Alex? So OpenChain is a working group. A lot of companies came together around 2017, all with a vested interest in developing and leveraging open source in that software development, to come together and say, what is the best practice process for managing the supply chain? And it started off focused on intellectual property and license compliance, so meeting all the obligations of open source licenses. And it's a process standard. It's basically, the key requirements are, have you got a policy for software developers, for the do's and don'ts of the use of open source? Have you trained your developers on that? Can you identify all the third-party components and libraries, which equates to, in effect, the SBOM? And when you ship your product or solution, are you meeting all the obligations of the licenses in the code? Now, because of all the issues around security and the regulations that are coming out, OpenChain as a project is expanding into security as well. So they've already got a working group looking at security, and they've issued an assurance standard. That standard is still being worked on. Anybody can contribute to OpenChain. So if you go to the OpenChain website, you can subscribe to the working groups, you can subscribe to email, you can attend events, you can get involved in drafting the standard. They reckon by the middle of next year, the security part of OpenChain will also become an ISO standard. Now, the idea is the benefit to a software company is if you have certified against that standard, you're basically demonstrating to customers, partners, prospective customers that you've got a process for managing that supply chain issue. Therefore, presumably you'd be a lower risk, both from security and a license compliance kind of standpoint. So yeah, feel free to get involved in that. Now we're just going to run a quick poll, just a few questions. So Cody, if you could run the poll, just to get your feedback on what you're seeing around SBOMs. So the first question's been put up there. So while we're doing that, Alex, obviously you develop a lot of software, or Revenera develop a lot of software. How are you seeing this as a problem? I mean, are you producing SBOMs or looking at standards?
So yes, I mean, clearly being in the SCA industry, we've been producing SBOMs for a long time, just kind of based on where we are in the market. But we're definitely seeing an uptick, and Sean can speak to it as well on the sales side. We're definitely seeing an uptick in any new deals and RFPs or RFIs around, can you produce an SBOM for your product? How do you deliver it to us? How frequently do you update it? What is the level of coverage in it, right? And there's an important distinction to a piece that Martin mentioned earlier around various regulations is a bill of material for a product that is delivered on premises and installed behind a customer's firewall is a bit of a different focus than a bill of material for a cloud offering, so for a SaaS application. So if you're delivering a bill of material, for example, to your customers, they're installing it behind the firewall, their interest is an enumeration of every single component that is inside the application, because the application now puts them at risk. It's running on their premise or in their cloud, and it's running in their infrastructure. However, if you use a cloud service from your software supplier, the focus is not so much on every piece of software inside that application. It's on all the potential attack vectors, right? So there's more of an interest around things like, what are the various endpoints, and do they expose my data? Is my data protected? Is my data encrypted, right, at rest and in transit? So there's more focus on ways that that service can be attacked and information can be stolen than there is on an enumeration of just the packages that went into building the application. So it's important to understand that, and important to understand what your customers demand from you, both on kind of level of depth and what they expect to be as part of your bill of material. And it looks here like we got a split. So half the respondents are being asked to provide SBOMs, 20% no, and which will become yeses over time, I'm sure. And then quarter of the folks are not sure. So good to know. I don't know, Sean, if you wanted to add anything from the sales side on this.
Yeah, I mean, just as you said, we are being asked pretty much for every opportunity nowadays. Can you provide us a bill of materials for the software that we're looking at? So it's as Alex mentioned, if you're not being asked, you will be. It's just a matter of time.
I think it's a two-way street as well. I mean, we have got another question about, are you requesting SBOMs from the suppliers? So we work with companies who've got their own supply chain. So if you think about all the tools you use in software development and cloud services, for instance, are you requesting an SBOM coming into your organization to assess risk about what you're developing on or with? So it's it's a two-way challenge, really.
Yeah, I think our second question will address that.
Yeah, Cody, do you want to pose a second question?
Yeah, and this is really important, because if the answer is yes to the first question, and it should be for most people, then you are dependent on your vendors upstream and any of your partners and suppliers to provide data to you. So unless you have the rights to receive any source code from your upstream vendors, and you can essentially handle it just like you would the code that you develop, you're kind of at their mercy, and then you need to get the software bill of material from your vendors. You need to join that with the parts that you're constructing for your bill of material, and then provide a unified view downstream. So we'll talk about this in a minute, and Sean will show kind of some of the things, some of the ways you can go about doing that.
Yeah, I was just going to say that adds a new layer of complexity.
Okay, so here, actually, a little surprising, so that's good. So a lot of people are asking for it. If you're not, I would definitely start for a couple of reasons. Number one, It's kind of a real quick litmus test on your suppliers and your vendors, and are they equipped to provide you one when you really have to have it? And then number two is it's a good opportunity to discuss common standards, right? So what format do you want to use? How deep do they go? Do they enumerate every single top level component? Do they look at direct dependencies, transitive dependencies, fragments of code, any other non-source code items, images, icons, documents? Right? You need to kind of agree on what's the resolution for your bill of material, what's in and what's out of scope. Are you going to do this in multiple phases over time? Are you going to try to create a perfect one first time through? And how often are you going to get an update? So these are all good things to discuss with your upstream partners.
Yeah, the challenge is, Alex, isn't it? It's you're going to get different formats. You know, if you don't define a format, you're going to get different formats generated by different tools, and then you've got to merge it with what your central reporting. That's always going to be a challenge as well. Cody, do you want to put the third question up related to training?
Yeah, and this is by far the most critical one because you don't want to be on your heels, right? So make sure that you've done internal training for your product teams, your development teams on what is a software bill of material, what is open source, what's an open source license, what's an open source vulnerability, how is that different to something your SaaS security scans will produce? How do you remediate open source vulnerabilities versus coding defects your own team introduces? Right? What are your internal policies for open source usage? So these are things that your product team likely did not learn in college when they were getting their computer science degree. So it's really important to make sure that you've got a program internally to make them aware if you're going to hold them accountable so that you set them up for success. Yep. So there you go. A third yes, 2/3 no. So really imperative to kind of move the yeses higher and the no's lower. So this is critical because if you don't start with a training, then it's really hard for people that are being held accountable to stick with open source policies and constructing SBOMs to be successful because they likely haven't been trained in how to do it.
Yeah, very interesting. So Alex, I talked about OpenChain, and I know Revenera have been through the process of adopting OpenChain and conforming to ISO 5230. How much of a challenge was that for you? I mean, it's not your full-time job, for instance, but I know you were heavily involved. Is it achievable for most companies, would you say? And where did you start with that?
Yeah, so definitely achievable. The beauty of OpenChain is it's not kind of a one-size prescriptive spec for all, right? A small organization versus huge organization can take a different approach to doing it. It can certainly be done team by team, division by division. It can be done in layers. I certainly wouldn't recommend that the first milestone is to get your entire company to be OpenChain conformant. Start with kind of a beta team, make sure that you kind of go through all the speed bumps with them, and then roll it out broader within the company. For us, the biggest challenge was to take everything that teams are doing, because we didn't start with nothing, right? Everybody was doing something. It just wasn't organized. So kind of understand what each individual product team is doing, what tools they're using, how frequently they scan, what policies do they abide with, and all that, and try to organize it, try to consolidate it, try to come up with a single process if you can. Make sure the process is flexible as teams come online, as you go through M&A activities, you maybe bring in new teams on board. Make sure that people are trained, make sure you have policy, make sure they understand the policy, and do this in phases, right? Don't try to boil the ocean, do it in slices. And each phase you go through, do a retrospective, understand what worked, what didn't work, and try to improve the next cycle.
I think the important thing, we work with a lot of companies as well, adopting and helping them adopt OpenChain. You touched on that. There's a lot of collaboration required across the company. There's different, kind of moving parts. It's not just software development's responsibility to manage this. You got things like you got to bring a team of people together. So there's a hot topic word at the moment is the Open Source Program Office, or OSPO, which is basically a team representative parts of the organization, isn't it? You created an OSPO, didn't you? So you can't do it in isolation or have one person just kind of be responsible for everything to do with OpenChain, can you?
Yeah, absolutely. I mean, you got to get legal involved because they're kind of the owners of the policy. You got to get security involved because they're setting the criteria for the product teams and what level of vulnerability is acceptable, what's the priority, how do you fix it, how do you prioritize vulnerabilities. You may need to get procurement involved because if you're going to start asking your vendors for a bill of material, it's likely going to come from IT or procurement. Creating an open source program office or an open source review board is a great step to bring all these representatives together into one team and meet frequently and make sure that the company is in sync on what you're doing. And ultimately, you need somebody who is the owner and is accountable for this entire process, right? That person can't do everything, but someone has to kind of orchestrate all the activities. There's lots of work to kind of get going and get off the ground. But once you get all of these folks involved, the process kind of feeds itself. So the key thing is don't do this alone. Don't do it with one person in a silo. Make sure that you're communicating across the company and with all the stakeholders because all of their management will push requirements onto them that ultimately will get pushed down to engineering. So it's important to get everybody's feedback along the way.
Sure. And I guess you need executive sponsorship, it's ready to really come down from the top and mandate it basically within the company.
Absolutely. Because you're going to likely disrupt lots of processes and enrich existing processes. So it's important for people to understand why this is being done, right? Why are we being asked to do SCA scans? Why are we being asked to prioritize fixing a vulnerability over a planned feature? So product management has to be involved as well. And there has to be common prioritization across products, right? You don't want one product cranking out features, ignoring security, while the other one is working on tech debt and fixing security and slowing down on features. You want it to be consistent across the organization, and you want to communicate this to your customers so they understand if, for example, you had to slow down on delivery of features because you need to make sure that you got your security posture under control. So yes, definitely important to get everybody involved.
Certainly. Interesting.
Yep.
So I think, Sean, if you're ready.
Yeah, so let me set this up real quick for what we want to demo. So I did want to spend a little bit of time kind of talking about the software supply chain and kind of what's the perspective from both sides of the supply chain. So this picture here depicts a very simple software supply chain, right? So your organization is the purple circle in the middle. You likely have one or more upstream suppliers, meaning if you don't write 100% of your own code, it's coming from somewhere. So whether it's an open source project, whether it's a SI partner, whether it's a contract developer, whether you're OEMing somebody's database and therefore their content ends up being part of your content, you likely have upstream suppliers. To the right of it are your direct customers. And in some cases, if you're selling things like software development kits or other modules that are going to get wrapped into your customer's application, then you may be selling to your partners downstream who in turn sell to their customers. So you may be in the middle of kind of both sides of the software supply chain. And when you look at it, there's really three kind of main activities there. There is the inbound bill of material, and how do you understand what you're receiving from outside the company? There's an outbound bill of material is how do you put everything together and deliver it downstream to make sure that your customers or your partners who sell to their customers get full transparency into what is inside the application. And then there's everything in the middle, which is your bill of material management. So we usually talk about this as there are various SCA tools out there. So Revenera has a product called Code Insight, lots of other tools out there. We definitely recommend people use multiple tools, right? There is no perfect SCA tool out there. Each one kind of caters to different use cases. So we see a lot of our customers who use our tool also use other open source tools to kind of give multiple data points around the composition of their products. So your SCA tools will give you visibility into the code under your control. The challenge is there's a blind spot because if you are receiving content from software vendors, so let's say you're OEMing a database, from partners, from external developers, you may not get code from them. You may get a binary, for example, or an image, and you may not be able to scan that as part of your SCA process. So it's important to make sure that you have a software bill of materials source of truth, which is informed kind of with two feeds. One is organizing all the data from your internal scan activities, from your SCA tools, but also to be able to consume the software bill of materials that you will receive upstream. So whether they're in SPDX, CycloneDX format, whatever have you, or in spreadsheet, for example, being able to ingest that, being able to reconcile that with parts that you're getting through your scans, and then being able to unify all that and deliver it downstream, right? So that's really the need, is come up with a unified bill of material that includes all the parts that you manage, all the parts that are coming in from the outside your company, being able to reconcile parts so you don't have duplicates, being able to interpret the data in their bill of materials to make sure that they are seeing the parts that are coming in, and then to be able to provide bill of materials in various formats depending on your agreement with your customers, whether it's SPDX, Cyclone DX, a human readable in Excel or HTML. That is something that needs to be agreed upon because they need to be able to process that at their company. But however, along with SBOMs, you got to also provide things like your third-party notices report, right? You got to maintain attributions for your third-party authors in the code. Also, security reports, right? There's really two main kinds. There's the vulnerability disclosure report, which is effectively saying, for all of my parts, here's a listing of all the vulnerabilities that have been reported against those components. There's also a VEX report, which stands for vulnerability exploitation, and that is more of a declaration of false positives. So out of the thousands of vulnerabilities that are reported, focus on the following, because we've done our own attestation, we've done our own assessment of each vulnerability, and we know which ones actually affect our application. So just to be mindful that there's kind of a holistic view of everything, and then a whittled down view of things that are critically important and ones that your customers need to focus on. Again, with the goal of making sure that at the end of the day, it's clean and you start trending towards less vulnerabilities in your application. And then if you look at all of the stakeholders that benefit from having a unified source of truth for your bill of material, so legal and open source program office, right? They're dealing with policy management. They're dealing with rules and timelines and SLAs on when things need to get fixed, which licenses are allowed, how do you get out of an issue if you have a license that's non-compliant. Security comes in and they deal with compliance alerts, they deal with impact analysis if there's a new vulnerability reported, they deal with the security reports. Product teams, right? They're the ones who get alerts if something falls out of compliance. So they benefit from being able to go into the system and say, are any new security or licensing issues impacting parts in the applications that I'm responsible for? IT procurement, this is a different use case, right? This is a use case where there's interest in understanding the composition of enterprise applications that are deployed either in your IT infrastructure or where you rely on a SaaS offering by one of your vendors, right? So it's not the code you create, it's the applications that you use. But going back to kind of the Log4j case, it would be great to know that there is an issue before one of your suppliers lets you know. So having the parts cataloged, being able to query them, being able to have alerts gives you early indication that there may be a problem. And then management, things like producing compliance artifacts, data rollups, usage insights, trends. These are all the things management needs to be able to properly allocate resources and focus on kind of hotspots across the company where more work needs to be done to reach the desired compliance state. So this is the flow that we generally recommend. So Sean's going to do a couple of demos here to talk about two main use cases. So I'll let you take over here, Sean, and introduce it.
Yeah, I mean, the first example or the first demo we'll talk about really is about the development that your companies do. As we mentioned, you do a certain amount internally. You have the ability to scan with different solutions and generate a bill of materials for the code that's in your direct control. But there oftentimes are other things coming into play, whether it be software vendors from the outside of your organization, maybe external developers, external contractors, or even potentially, you're bringing in commercial content and embedding it with your application. So you want to be able to generate a complete bill of materials that really describes all of that. And then the second aspect really is kind of looking at the other side where, as Alex mentioned, for IT and procurement, getting an understanding of, what is out within your infrastructure to understand what potential risk there could be when a new vulnerability is disclosed, so you can be proactive and ensure that you really are aware of where potential issues are. So let me share my screen real quickly. And this first screen here really will be looking at kind of a view as to, here is the code that I have with my control. So here's a, kind of a view of what an SBOM would be, where we have the actual part, the version of the component and the license, and we also have visibility into the vulnerabilities. But really, as we said, this is kind of half of the picture. So what if I have been provided a Cyclone DX or an SPDX document from one of my vendors, what do I do with that? Ideally, you'd be able to take that information from the vendor and incorporate it and add it to the information that you have within the system based on your scans. So quickly, to kind of show that, sitting here right now, based on my code, I have, 3 components with vulnerabilities, a total of 9 components. So let me actually bring in an application and kind of append it to the information that I have within my system. So if I import that, this is really bringing in that information that I received from my vendor or my supplier and bring it into this bill of materials to allow me to get an entire picture of really what's inside my system. I go back and look at this item. So I now have gone from 9 to 14 components in this simple version. And once again, I've gone from 3 items that had vulnerabilities to 4. And what this allows me to do then is actually generate reports and things that I can then provide to my customers. Example of that could be, say, a vulnerability report that really highlights, all the potential issues within the application based on those components that are being included. Above and beyond this, we have the ability to generate, third-party notices because, once again, we have a complete listing of everything within this, as well as, an SBOM ourselves that we can provide downstream, whether it be SPDX, Cyclone DX, so that they could potentially take that and then do something with that as well. And then really, it's really the same information, the same view, but, the ability to look at what is being deployed within your infrastructure also is very important. So for example, if I'm curious about, what's being installed, what are my teams using for development purposes? Maybe we have a Jenkins installation on our network somewhere. So I went out and I found a bill of materials for Jenkins and then brought it into the system. So now I have the ability to query as well as take action on information that's been provided to me from my vendor for solutions that I'm using in-house to once again have the ability to be proactive, understand what's in there. If a new vulnerability has been released, do I need to take action? Do I need to reach out to my vendor to say, when will you have an update available to this without me having to wait for them to approach me? Okay.
Yeah, and I kind of want to jump here. So this is a really critical point that Sean just mentioned. So if you roll back to last December when the Log4j event occurred, so everybody who is a software producer went back and either scanned or looked at their historical scans to understand whether they're using Log4j and whether they're putting their customers at risk. Meanwhile, if you look at your IT team, they were scrambling to scan your corporate infrastructure, right? What applications do we have deployed? Is our network at risk? Is there a way to get into our network through this particular vulnerability? So they were kind of, number one, scanning what they could, and they were sitting waiting for all the software vendors to send them some sort of notice of, we have Log4j, we don't have Log4j, we've patched it, here's where the patch is available. So the benefit of proactively having their SBOM ingested and represented as parts for which you can get alerts and are queryable is you don't have to wait for the vendor to reach out to you. You should know right away that we got Jenkins deployed. Jenkins has 2 components here that have vulnerabilities. I can reach out to them and ask them about the patch without having to wait maybe days or weeks till they reach out to every one of their customers to let them know what's going on. So it kind of shifts your power position to have insights early without having to be at the mercy of every one of your vendors reporting out to you, because some of them may take a long time to do that. Okay, so to close this out, we wanted to focus on, get my slides back up here. So I wanted to focus on, so given all this information, kind of what do you do, right? Where do you start? So there are kind of 6 main steps that we think are a good place to start and things that every company should be able to take action on immediately. So number 1 is understanding your ingestion process. Right. This is where you really need to work with your product teams and understand, where does third-party content enter your company? Is everything dealt with through package managers and manifest files? Is there some mythical Z drive from where your build pulls and there's content that somebody archived on that drive years ago and people are afraid to break the build so they never remove it? Do you have any sort of consistent sourcing process? Do you have policies around where code can be grabbed from and where it cannot be grabbed from? Do you have any sort of developer vetting process? Right, understanding all that will give you essentially a set of potential risks that you can then work on mitigating. So that's kind of the first step. And I'll let Martin comment on that.
Yeah, I talk about number 2, number 3 almost together. So we talked about collaboration. Although we're talking about code, it's not just about software developments. There's legal, procurement, commercial, architects, software developers all need to come together to work out, the journey you're on, where you are now and where you've got to get to. And to do that as well, you've got to invest in training to get everybody on the same page and the same level of understanding. So when we train companies, there's always a varying level of understanding about different aspects, such as licensing, what is open source, what is SCA, and things like that. So the training and the collaboration kind of go hand in hand, and they should be at the start of the project, and it gets you on the first kind of step of the journey towards getting to a point where you can produce an accurate software bill of materials or ingest software bill of materials from suppliers.
Yep, absolutely. And as part of training, you're trying to change the culture of your product teams, right? And making this kind of a secondhand activity or a second nature activity. So I always like to position this as yet another automated test process, right? Developers have been trained for years on the benefits of automated testing. This is just another class of that, right? So you test for coding defects, you need to test for composition, test for adherence to your policies, and have procedures to treat it as, with the same level of importance as a defect that is found by QA or an automated test. So number 4, invest in SCA tooling. So it's important to understand that there are kind of 3 elements to security, right? There's your static code analysis to make sure you find any sort of vulnerabilities in the code your teams wrote. There's dynamic and pen testing to make sure that at runtime, your product is secure. And then there's the open source part, right? There's the code you didn't write. So that's where the SCA scanning comes in, is running static code analysis is on the code you wrote. It's not going to scan third-party content that is being pulled in the way of binaries. Pen test will find issues at runtime, but it will not find inherent vulnerabilities that are not necessarily exploitable in the version that's being tested. So it's important to get a grasp on what is all the third-party content coming in and which items have vulnerabilities, which items need to get either upgraded or mitigated through code changes on your side. So having SCA tooling in place and having it integrated into your process will be able to cover that blind spot.
Yeah, and I guess I'd add to that is, theoretically you could do it manually, but you will always be behind the 8 ball. You're always going to be trying to scrambling to keep up. So tooling definitely is important, just to try to, allow it to be automated in some fashion. So it's always concurrent with the current development state.
Yeah, which feeds into point 5, which is shift left. A big pushback we hear from customers around this whole process is it's going to disrupt developments. It's going to delay software release cycles. Everything that we talk about, so having a policy, you can integrate into SCA tooling, put the power into software development, and shift further left into the design and development. And if you fix issues early, it's a lot quicker to do that. It's a lot cheaper. So if you've already shipped a product and you've got flaws in the product, whether it's to do with licensing or security, it's going to be far more expensive to get a fix out to a customer. But if you've got that shift left automation, so a developer pulls in a component with a vulnerability, you can address it right at the beginning of the development process. When it comes to building the final software bill of materials that you might share with a customer, it'll be far easier to do that final process. It should be a final checkbox exercise at the end if you've adopted shift left effectively and have that automation in place. And if you do that as well, you won't delay release cycles either. It just becomes a natural part of software development within the company.
Yep, absolutely. And then finally, start constructing SBOMs, right? You're going to be asked to do it. It'll become a requirement in the future. Kind of figure out what works for your company. How often do you do it? Who's responsible? What do you do with it once you construct it? How do you deliver it? We're looking into things like developing a customer partner portal to let people self-service versus having to send documents around. It's important to look at that, right? Because if you have 1,000 customers, you need to go deliver 1,000 SBOMs times the versions in your product. That's a full-time job. So you got to really plan it out, get good at it, figure out with your customers and with your downstream partners what has to be in the SBOM when, right? Do you need a complete one today? Do you start with top-level components, then go to dependencies, then go to fragments? Do you need to go to fragments? Right. So really, this is not a unilateral decision to be made. You need to understand what industry you're in, what the regulations dictate, what your customers demand of you, and what their customers demand of them, because they're relying on you to be able to satisfy their downstream requirements as well. So definitely have the conversation and have essentially a project plan and a roadmap on how you're going to get better at doing this and making it more complete and more accurate.
Yeah. And I got to say, don't wait, start now.
Yep. Don't wait to be asked.
Right. Okay. So with that being said, thank you for the time. I think we do have a few questions, so we're happy to take those.
Perfect. So we'll just take them from the top. Can SBOM dependency refer to licensing?
So software bill of material, kind of at its core, is a listing of components and versions with an addendum to talk about security vulnerabilities. Now, both SPDX and CycloneDX format in the spec also includes attributes to explain licensing. So answer is yes. The important use case around licensing, so it's two, right? One is clearly, is the license for this part compatible with your policy? But secondarily, for security folks, you may be stuck and prevented from upgrading if a license change occurred and the new license is not compatible with your policy. So it's important to understand discrete license changes. If something went from a permissive license to one that is not compatible with your policy, you may be stuck on a version, and over time, that version may become insecure. So even though it's not directly a security issue, it is kind of indirectly potentially a future security problem. So it's important to understand licensing implication of dependencies as well.
Plus, Alex, there could be obligations that conflicts with you as an organization. There's been quite a number of new licenses and license changes which have affected companies. So for instance, if you develop cloud solutions, Elasticsearch changed their license policy. You used to have a free open source version under Apache. They changed it to a modified open source license called the certified public license, which has an obligation that you have to share your whole solution stack. And if you have to share your code that you weren't planning to share, you could reveal weaknesses in your code, which could become a security issue. But there's other obligations as well. For instance, a copyright holder who finds out you're using their software in your software might decide to pull the components. We've seen that happen. And then you've got to update all your customers and remove that component and find an alternative way of delivering that bit of technology. So licensing is, not just about compliance, it can have an effect both on security as well.
So what are your thoughts about component level scan? Do you think code audit is enough to be OSS compliant, or a detailed clearing at component level is also required?
So the first step in understanding your security risks and building an SBOM is getting the composition down, right? So you can't secure the parts you don't know about, right? So certainly you need to understand what is demanded of your organization. So for example, is Linux a single line item in your bill of material, or is Linux going to be broken down into the thousands of components that make up, Linux kernel and the link modules? So there's another question I saw in the chat around, how deep do you go with dependencies? Kind of a related question. It depends, right? It depends on who's consuming your bill of material. If you are working, on an operating system that's on Mars, like Windrover does, then you are going to be expected to be very meticulous in everything, because kind of the cost to remediate is outrageous. If you are, a component that's not used in government, not used in a regulated industry, and it's, a dashboard application, and certainly kind of the burden is lower on you. So you have to understand what ecosystem you're in, what is demanded of you downstream, what your customers demand, what your industry demands, what your customers demand of them if they're using your part to build their product. And it has to be an agreed upon kind of level of depth. So there is no one answer. In a perfect world, everything should be in an SBOM. Realistically speaking, the frequency and the churn of code and kind of the cost to build that may be prohibitive in some industries. So you have to understand what you need.
All right, well, we are at the top of the hour. So before I kind of clear you guys off the floor, I wanted to give you a chance to address the audience if there was any closing remarks you'd like to make before we go off air.
I would just say if you're just starting looking at this as a challenge or a problem, don't go too big. I think Alex talked about maybe pick a project, prove your process, prove the tools you're using, and then expand out into other parts of your organization. I've seen too many companies try to do everything all at once, fail, and then never recover from it, really.
Alex, Sean?
Yeah, I guess I'd say, as I mentioned earlier, don't wait to start. Get going as soon as you can. There are a lot of people out there, a lot of organizations out there that are willing to help and provide advice and suggestions.
Yeah, and I definitely agree with both of those comments. I would say there's tons of resources out there. There's lots of industry groups. There's lots of meetups. Get onto SBDX meetings. Get into the Cyclone DX community. There's OSPO meetups. There's CISA weekly meetings for tool vendors, for SBOM consumers. So if you don't know where to start or where to go, there's lots of free resources out there. So don't kick it down the road. Make sure you engage and get going.
Perfect. So Alex, Martin, and Sean, thank all three of you so much for joining us for the last hour. I do need to just run through a couple of closing housekeeping remarks. So we do have 4 $25 Amazon gift card winners, and they are Regina P., Adam S., Ginny G., and Yaniv O. So to our 4 winners, congratulations. Keep an eye on your email inbox to check or to claim that gift card. But if you don't happen to see that email, do check your spam folder. I'd also like to remind everyone that this session was recorded. So you should be receiving an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars. I'd like to thank Revenera for sponsoring today's program. And to our audience, thank you so much for sticking with us these extra 2 minutes while we address these final questions. We do just want to ask for 1 more minute of your time for a brief webinar survey that should come up on your screen as soon as we close out. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Everyone have a great rest of your day. And Alex, Martin, Sean, thank you all once again.
Thank you.
Thanks, everybody.